Welcome everyone to topic 7.13, pH and solubility. By the end of this, you should be able to identify the qualitative effect of changes in pH on the solubility of a salt. So we can also apply equilibrium concepts to weak acids and weak bases. Consider the equilibrium for the weak acid, formic acid, HCHO2. Note that weak acid equilibrium expressions are labeled with Ka, because it's the equilibrium of an acid, but it doesn't dissociate to completion, so we can write an equilibrium expression for it. The addition of an acid, Ha, would make the equilibrium shift to the left, as the H plus ions would react with water to form the hydronium ion and drive the equilibrium to the reactants. The addition of a base would make the equilibrium shift to the right. The hydroxide will react with water, or with the hydronium ion to form water. The removal of the hydronium ion would drive the equilibrium towards the products. So in this, we need to make sure we're accounting for reaction changes with additions. So if we add something, but it's not directly present in the equation, we have to look, is it going to react with something that's in the equation and possibly remove it from the system that we're studying. So a similar situation will take place for the equilibrium of a weak base if we consider ammonia. Note weak base equilibrium expressions are expressed with Kb because it's a base, but it's weak, so it doesn't dissociate to completion, and thus equilibrium will be reached. An addition of an acid, Ha, would cause the hydrogen ion to react with the hydroxide ion to form water. This drives the reaction to the right to re-establish equilibrium. The addition of a base would drive the reaction to the left to re-establish equilibrium. Okay, so let's look at some I-dos. We will look at this again further in a future lesson, or a future section. Not this unit, but unit in the future. Okay, so the equilibrium includes two colored species. The chromate ion is yellow while dichromate is orange. Predict the color. So this one's yellow over here. And over on this side it's orange. Okay. Predict the color of the reaction vessel after each of the following additions to a system at equilibrium. Okay. So when we add the hydroxide, we have to think of what is this going to react with, because I don't see it in the reaction. Well, a base reacts with acid, so that means that this hydroxide is going to react with this hydrogen ion and remove it from the system. It also produces water, so this is being made. So we're removing and adding, removing from the reactants, adding to the products. This reaction will then shift left. That means that this reaction will become more yellow. If we, though, add an acid, so we're going to add here. Remember, we shift away from additions, so this is a right shift. And so it'll get more orange. Okay, so the addition of barium nitrate. Barium chromate has a solubility product of 1.2 times 10 to the negative 10. Where barium dichromate has a very, very large. So we have a very small solubility product and a very large. What that means is that this one is going to precipitate. This one precipitates, so we remove this from the system. So we're removing here, so we're going to shift towards the reactants, so it is a left shift. And this, therefore, becomes more yellow. Okay. So I want you to pause the video and work on the we do yourself, and then we'll go through it once you've tried. Okay, so you should have watched the video. For this, we look at the addition of calcium. We add here, which means it's going to shift this way, which means this goes down. Okay, so the carbonate ion decreases. So this is being lost, so we're going to shift towards that loss to make it back up. Okay. Wait, I'm going backwards on that. I'm sorry. I read what happens if you decrease the calcium ion. My apologies. If you decrease the pH of a solution, so remember acid solutions or acidic solutions have a higher concentration of the hydrogen ion because it's a negative log function. So if we're decreasing the pH, that means that we are increasing the hydrogen ion concentration. So we're going to shift towards this direction. Okay. That means that we are losing this. So this decreases here, which means that we will try to make more of it in another reaction to keep reestablishing equilibrium. So that means that this is going to shift to make more. So then the calcium ion increases. So the calcium ion concentration would increase. Okay. And this is actually what happens with ocean acidification. As the pH of the ocean decreases, which it is slowly doing, the equilibrium of the system utilizes the calcium carbonate found in shells and carbon dioxide that then forms carbonic acid in water to maintain pH balance. Well, if we have too much acid, what ends up happening is shells and other things containing calcium carbonate in the ocean are used up to produce more carbonate ion to then react with the hydrogen ion and reestablish the equilibrium and force the pH to not change as much. Okay, so this concludes the notes. Complete the you do, check your answers, and thank you for tuning in.